Alrighty, my friends. Well, first of all, how are ya? Oh, that's just terrible. Come on, try again. Terrible. I appreciate it. Look, we don't have a lot of time. As far we've got 45 minutes-ish, a little bit. So we have very little time. And, I want you to be happy that you're here. I'm certainly happy that I'm here. I'm happy to be with you all today. Thank you so much for coming. Is this going to go? The clock? All right, I'll just take 2 hours. It's fine. I am a big Dr. Venkat Subramaniam fan. So I would have. I feel like you missed something. That was a good one. That's the best, right? That's the best speaker in the business. Hopefully you got something out of it. Hopefully he was able to recover. I have no doubt he did. He's amazing. We have very little time, like I say, as always. Because we have very little time, I encourage you to take a photo of this one slide. This one slide has all the code that we're going to follow along with today, all the code that we're going to look at today. It also has my Twitter coordinates. How many of you, by show of hands, have Twitter? I'm just curious. Twitter 2019, Twitter 2019, Twitter. All right, the rest of you, get on it. What are you doing? It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are. So you should be there. That way you can reach out to me, talk to me, ask questions, and all the other people in the open source community. What about email? How many of you are using email? Email. Anybody? Email. No. Good. Moving on. I'm not really a big email fan, but I think it's probably better than Slack. It's taken a while for me to come to that appreciation. So Twitter, email, Slack, right? And I have a brand new MacBook Pro. This is a brand new MacBook Pro from last year with 32 gigabytes of RAM. That's a lot of computer, my friends. And I tell you this only so that you can understand, when you want to go buy it, you can understand that yes, you can successfully run both Slack and Chrome at the same time. That's a big deal for me. I wasn't able to do that before. A little bit about me. My name is Josh Long. I work on the Spring team as a developer advocate. If you're in China, this is a great thing to know about, but if you're not, here are some videos that I do on Safari. These are on the all-you-can-eat sort of technical marketplace. It's a buffet for technical content. It's like Netflix, except that you don't get stupider. So that's nice. Lots of videos there. They're like 5, 6, 7, 8 hours each one. Lots of good content there. I have a book called Cloud Native Java that's all about how to build applications that survive in production using Spring Boot and Spring Cloud and Cloud Foundry. And the book is something that I'm very proud of. It's something that took a long time to get right. And there's a good reason that we were so delayed. We finished the book pretty quickly, but there was a long debate, a long back and forth, a long discussion that we had with our publisher, O'Reilly, that took a little bit longer, not much longer, okay? We took like 6 months to write the book, and then it took another, not very much, very little, like 2 years, okay? It was not a big deal. The extra 2 years we spent debating the animal on the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't matter what's in the book itself. Obviously, nobody cares. Have you ever read these books? No. Look at all the Amazon reviews. It's just great animal, good choice, great selection. We eventually settled upon a blue-eared kingfisher. It's a bird. It's a bird with blue ears that is only found in the Indonesian Java Islands. It's a bird that is only found in Java. It's native to Java, and birds fly, yes, through the clouds, yes. So it's a cloud native Java bird. Never mind, it'll come. Give it time. I have a podcast every Friday called The Beautiful Podcast. I do videos every Wednesday. That's a Spring Tips playlist. You find me doing hour-long introductions to all sorts of different topics. How to use Spring in Google Cloud, Alibaba Cloud, Microsoft Azure, how to use messaging, integration, security, OAuth, everything, all sorts of topics, circuit breakers, whatever. And I have a new book called Reactive Spring. And this book is all about how to build applications using reactive programming. And that's what we're going to talk about today, my friends. And it's a very exciting thing to discuss. It's exciting, but it is not new. Or really, actually, reactive programming is kind of new. But the problem that it solves is very old. Okay? The problem that we're trying to solve is, how do I handle more users in my system, as I add more capacity to the system, how can I scale the number of users I can support? And if you have been following the patterns and the trends from the last 10 years, then you are already building microservices. You're doing cloud-native applications. You're doing 12-factor app-style services, stateless, small, singly focused microservices. And these services are cheap to scale out horizontally. You can just put them in a load balancer and then randomly load balance load across the different instances, and you're fine, right? That's a very easy pattern to do. All cloud infrastructure today will do that for you. It's a built-in thing, no problem at all, right? This is a useful pattern because it allows us to handle more users. The reason we do this is because we can't handle infinite numbers of users on one machine, right? So we talk about like Netflix, the cloud-native architecture from 10 years ago, right around the same time as QCon first came out, right? Congratulations. The first cloud-native architecture was, hey, let's get stateless microservices and Cassandra. So all the state is in the database, and the database scales horizontally, okay? And the reason that's such a useful pattern is because you can write applications that are just HTTP APIs, and even if the HTTP API is not super efficient, who cares? You can just add more app instances. I work for Pivotal, and at Pivotal we sell cloud computing technology. So I love that answer. That's a great answer. Every time you scale out, companies like mine make more money, right? It's awesome. I love that. I love it. But there's a question. Why can't we do more with the same machine? How do we handle more users with the same hardware? Right? The question is, how can I do more with the same computer? Not how can I go faster per transaction, okay? And if you're asking that question, there are some, oh yeah. Ah, good stuff, thanks buddy. The question then is, how do I handle more users in the same computer? Obviously, there are some interesting answers here. You've probably heard about the C10K problem, the 10,000 concurrent users problem. And this is a very simple problem posed 20 plus years ago. The question is, how do I handle more than 10,000 users at the same time on a single machine? The answer is not with threads, right? Threads are actually a bit of a problem. And so think about how most traditional approaches to input and output work. You have a web server, and each time a user comes in, a new thread is created. And in that thread, a response is produced. And while you're producing the response, what are you doing? You're calling the database, waiting for the bytes to come back. You're calling other APIs, other gRPC or REST or whatever services, right? You're making network calls across the wire. You might be calling things in the file system, might be sending messages over to message queues. And all the while, as this is happening, you're waiting and waiting. Bytes are coming back and forth, and you're sitting on that thread waiting for the bytes. The problem is that while you're doing this, you're stuck on that thread. That thread is not usable for anybody else. It's unavailable. So the question is that okay? Well, can I just scale out infinitely? Can I just add more threads forever? And of course, the answer is no, right? I'm sure you've all tried creating like 1,000 threads. That's not going to be a great result. And there's a few reasons for this. First of all, threading is an illusion. It doesn't actually exist beyond the number of cores you have, right? Beyond the number of cores, you're just scheduling. You're doing work very quickly and moving it from one processor to another. So after that, you're just going to be thrashing. There's a cost for context switching. Now, even then, can you do the thrashing? Can you do the context switching very fast? That's actually a slow operation. To go from user space to the kernel and then back again for code like that, that's slow. So you're not going to have a lot of good results if you create a large number of threads. And also on the JVM, each thread takes about 1 megabyte of space, RAM. So if you have 1,000 threads, you've got a gig of extra RAM, right? That's before you've done anything. You haven't solved any problems yet. You've already wasted a gig. So this is not a good solution. So the question is, what can we do to be more efficient with the threads that we've got? And we can look back at that situation I just described, where we're waiting for the bytes to come back. And the reason we're waiting for the bytes is because we are using synchronous blocking input and output. So the answer here is to use asynchronous I/O. Asynchronous I/O is not a new idea at all. In fact, it's been in Java since 1.4, right? 1.4 came out in 2002, 17 years ago. Hi. So it's been around for a long time. You can use it to great effect today. It's already been there for 17 years, right? You know what that means? If it's in Java, it's in every single operating system that supports Java has to already have good support for asynchronous I/O. And this means that every operating system that supports Java and has asynchronous I/O support has had it for at least another year or two more than Java, right? I mean, that, you know, they don't just throw that into Java immediately after it's added to an operating system. They let it stabilize a little bit. So this means that every operating system for at least, let's say, 20 years has supported asynchronous I/O. Even Windows. Windows. Imagine. So we have asynchronous I/O support. Why don't we all use this? Are you all writing code using java.nio? Is your everyday line of business all about that? I think not. I think most of us don't write code that low level. Most of us don't write code that low level, and we don't use Java I/O either. We use higher order abstractions. We have collections and things like this. These collections, these abstractions, map nicely to the underlying machine, to the mechanism that we use for input and output. Now, we need something that supports that same kind of mapping for asynchronous I/O. And this is where the Reactive Streams specification comes in. The Reactive Streams specification was defined by at least 4 different companies, maybe a few more. You've got Pivotal, you've got Netflix, you've got the Eclipse Foundation, you've got Lightbend. They were called TypeSafe at the time. Right? All these different organizations got together, and we defined 4 very simple types. These are kind of like asynchronous arrays. They're the Reactive Streams types. They're very useful, but they're kind of like an array. They're not high level enough. Most of us want operators so that we can deal with streams of data. This is where we get Project Reactor and RxJava and Akka Streams and so on. These projects support higher order kind of computations on streams from these Reactive Stream types. Is that enough? Can we go to production yet? The answer for most people is no, not really, right? What good are those types if they don't support working with other kinds of infrastructure, if they cannot support us in our efforts to build business software to deliver into production? What good is that, right? Imagine, for just hypothetical, just an imaginary scenario. Imagine that for whatever reason, okay, that these technologies, these tools that we are familiar with, the ones that we have used for so long, imagine that these technologies did not understand or support Java util collection types, like Java util list or Java util array list. Imagine, for whatever reason, that whenever you tried to use Hibernate to map a one-to-many relationship, okay, imagine that it didn't just throw an exception, right? It really hates Java util collection. Imagine, obviously it does not, but imagine it did, right? It really hates Java util list and set. It really hates it. It doesn't just throw an exception. It actually renders an ASCII art middle finger. And then kernel panics the machine, right? Would you continue to use this if you knew that you could expect this kind of abuse? Of course not. You would use whatever Hibernate told you to use so that you could get software into production. Your job is to go to production and to deliver business value. It's not to figure out how to reinvent Hibernate, right? You can do better. You will do better. So you just use the path of least resistance. The same is true here. What good are these Reactive Streams types if the software that we use to deliver business value don't support them? And so this is where, for Spring, a big day came in September of 2017 when we released Spring Framework 5, and then Spring Boot, and then Spring Data, and Spring Security, and Spring Cloud. All these releases after that supported Java 8 as a baseline and the Reactive Streams types and a Reactive Web runtime. So my friends, today, we're going to take a very quick journey and look at all these different components, all these different pieces, and see how they help us build better software faster. And of course, to do that, we're going to go to my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. But if you haven't been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before your cup of tea or guarana, start.spring.io. If your children are restless and cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse, and WebSphere. Start.spring.io. So we're going to build a new application called the reservation-service. And we're going to use Spring Boot 2.2 snapshot. And we're going to bring in OurSocket, and we're going to bring in Lombok and the Reactive MongoDB support, Reactive Web rather. There we go, Reactive Web. And we've got all the good stuff that we need there. I'm happy with my selections. OurSocket, Lombok, Reactive Web, Reactive MongoDB. I'm going to hit generate, and that's going to give us a new zip file. And I'm going to open up this zip file in my IDE. So I'm going to go here, cd downloads, UAO. Woo, where'd it go? Still waiting. Oh, there it is. Wow, the Wi-Fi. Who's torrenting? While we're waiting for this thing to start up, I would need to do something very important. Just pretend like you're happy, and when I say open source, you say open source, okay? Ready? Open source. Open source. Oh, Flash, why? Good stuff. Obrigado. All right, so my friends, this is downloading the internet. Come on, go faster. So we have a new application. It's started up. It's a public static void main Spring Boot application. I'm going to make the font just a little bit bigger because I appreciate that you probably can't see it from all the way in the back there. Let's see, 24. How's that in the back? Great? Okay, very good. So we're going to keep this like this. And what I'm going to do is I'm going to build an application that writes data to the database. And I have MongoDB running in the background on my local machine. So it's going to be an object that we're going to map. And it's going to have two fields, ID and name. We're going to say at ID and then name. And so it's going to be a document. Now, in MongoDB, a document is a single row. And you have a collection, which is multiple rows, right? It's like a table. So this is the essence of what I want to express. But of course, it's Java. So getters and setters and toString and constructor and, you know, equals and hash code. Oh, so modern, so good. Right? Right? No, okay, probably not. Okay, so we get rid of that and we use Lombok. Lombok is a compile time code generator. It's an annotation processor. And with that, I have my getters and setters. Now, what I want to do is to write data into the database. And I'm going to create a repository, which is a pattern, of course, from domain-driven design. And it's a thing that handles the boring read, write, update, and delete logic. This interface, we don't have to implement it. We just define it. And Spring will provide an object that supports these methods. Obvious methods like save, save all, find by ID, check if it exists, find all, delete, count, etc. All these things that are very obvious. The names are obvious, but the types might be a little different for you. First of all, here's a publisher. A publisher comes from the Reactive Streams. It's one of those 4 types that I was telling you about before. Reactive Streams is a thing, the publisher rather, is a thing that publishes, it emits, it broadcasts items of type T to a subscriber. The subscriber listens for the item, and whenever the item arrives, onNext is called. When there is an error of some sort, throwable is given in the onError method. Now, keep in mind, in reactive programming, it's kind of functional programming. And so in this respect, errors are not special. They're not exceptional, right? They don't get their own control flow mechanism. You deal with them in the same way that you deal with any other kind of error. And then finally, we have onComplete, which gets called when they're done processing the data. Now, I skipped over this because this is the most important part. When the subscriber subscribes to the publisher, it is given a subscription. And the subscription is used by the subscriber to ask the publisher to slow down. It's very important. So when the subscriber is being overwhelmed, it can request just 5 records, or 10, or 1,000,000, or whatever. And so it will not get more than this. This is called flow control, right? We ensure stability by slowing down the publisher. In flow control, in the world of reactive programming, we call flow control back pressure. So if you have seen back pressure, if you have heard that word before, now you know what it means. If you want to cancel the production of data, you just call cancel. And there you go. That's 3 of the 4 types. The 4th type is called a processor. And that's this one right here, processor. Subscriber and publisher. That's it. Now, I forgot to do something very important on the Spring initializer. I'm going to use Java 11. That's the only sane choice in 2019. So I'll go ahead and add that. And now, I've got my application. Let's write some data to the database. So I'm going to say sample data initializer And it's just going to be a Spring Bean that listens for an event, application ready event.class, public void go. And when the application starts up, this Spring Bean is going to be given a callback. I'm going to inject a reservation repository like this into the constructor. I can do that like this, or I can use Lombok and say at required args constructor. Not bad, huh? So what I want to do is I want to write some data to the database. I'll say flux.just, and we'll have some names here. So I've got Louise, I've got Josh, I've got Anna, I've got my friend Spencer who speaks the Portuguese. Here we go, Spencer. I've got Cornelia. I've got Veronica. I've got Madura. And who else? Olga. Okay, so different names, just different 8 names. Okay, I've got a publisher, a Reactive Streams publisher. And now you haven't seen this type. Flux is from Reactor. Okay, Flux is it extends publisher. You can see it's a publisher. But Flux also supports operations, you know, flat map, map, filter, all these kinds of things, above and beyond regular publishers. It publishes 0 to X values, where X could be unlimited, okay? So I have a publisher of names, and now I want to map each name like this, new reservation, null, passing in that. And that gives me a publisher of reservations, res, right? And now I want to map each one of those. So map R, and I'm going to save this to the database using the repository, so saving that in. Now, what does map do? Map takes the return value from the Lambda, and it collects it into a container type. And what does save do? Well, save returns a mono. You can see it says mono of reservation. A mono is another publisher. It produces, at most, 1 value. Okay, so I've got now a mono, and I've got a publisher. So this is not what I want. If you look at the result, I get publisher of reservation. I don't want that, right? I don't want both. So here's that. Okay? That's not what I want. Instead, I want to get just the publisher, just one publisher. So I say flat map, and I get rid of the intermediate type. Okay? So there we go. Now, if I run this code, obviously there's some opportunities here to clean it up. I can say saved. I can do that. Now if I run this code, what happens? The answer is nothing. Nothing is going to happen because I have to activate the stream. It's a cold stream. In order to make it hot, you say saved.subscribe. Okay? Now, if I run this code, we will see some problems. First of all, when I run this code multiple times, I'll have 8 records in the database, and then 16, and then 24, and then the same data over and over. So I want to delete everything. Can I just do this? What about this? This, .reservationrepository.delete all. Well, delete all returns a publisher, so I have to subscribe. The problem with this, of course, is that it's asynchronous. This could execute on a different thread. So I need to force this to happen before this. I could do this. Oh no. This code makes me want to take a shower. This is not what we're supposed to do. Instead, use the operators here. So I've got a publisher. So what I want to do is I want to turn this code into a nice single pipeline, a single intermediate staged pipeline with multiple pipeline stages, okay? So here we go. Good. And now I'll say just. So I'm going to say delete everything, then write the data to the database, and then find all the data. And then finally, when all the data comes back, let's log it out. And I'm going to use a logger, again, from Lombok, right? Look at that. Good stuff. Okay, now run this. Let's see what happens. Is it going to work? Look at that. There we are. It worked. We're all there in the database. You can see the unique IDs, the names, everything worked. Of course it worked. It was a demo. What were you expecting? No. What I wanted to talk to you about is this. This is the Spring Boot ASCII artwork. This artwork took a long time to get right, but we on the Spring team have many people who are doctors, PhDs, and they worked very hard on this artwork. So it makes me very sad, and it makes me want to talk about this very problematic feature in IntelliJ, something that I consider a serious flaw in the product. Do you see this checkbox? This one right here? This checkbox? That one. Do you see that checkbox? This one right here. Do you see it? That one? That one. If you click this checkbox, it suppresses the output of the ASCII artwork. What the hell? Why is this there? That's a dumb feature. Nobody even asked you, IntelliJ, okay? So I did what everybody would do. I went on the internet and I cried. I complained on the internet, and I was sent a message of hope from my friend Jan Sabran, who's a software developer by passion at JetBrains. This is Jan. That's Jan. That's right, him. Boop. He sent me this message, which I want to share with you here today. He says, don't worry, Josh, the next release will no doubt contain this feature. It'll be fixed in the next release. Just relax, Josh. He tells me all the time. And we have been friends for a long time, and I want to believe him, but you know what? I'm starting to think maybe he's not being serious. Anyway, we have good SQL work, we have data in the database. Now, we need to have an API. So we can do this using the new functional reactive style in Spring Boot, okay, in Spring Framework. And so you do this. I'm going to define a bean, like so, hit build. I'm going to create an endpoint that serves all the reservation data. Okay, so I'm going to say, and then in order to do this, I'm going to inject my repository. So I'll say new handler function. Okay, I'm going to say return a server response.body, and I can say rr.findAll reservation.class. Okay, so there's my handler function and my builder, and it's a nice lambda, so I can remove that. There you go. There you go. My brand new HTTP endpoint. So let's restart this. Localhost 8080/reservations. Okay, there's my HTTP endpoint. Not bad. I've got an HTTP service, not a big deal. Now moving on. I like HTTP. It's awesome, obviously. But a lot of people ask me, well, can I use asynchronous protocols, right? How do I do that? Well, of course, in this case, remember, findAll just returns a publisher. So even though there's only 8 names, only 8 records, it's still an asynchronous stream. Everything in the reactive world is a publisher. And so it makes life very simple. What if you want to do WebSockets? Well, you just use publishers, right? So WebSocket config, okay? And you just create a bean like this, simple URL handler mapping. And all this is going to do is it's going to tell the framework how to expose, how to mount a particular service. So I'll say map.of, like so, ws greetings. And I'm going to inject a WebSocket handler. And the WebSocket handler will have the actual business logic, and we'll define that in a second, okay? So there's my handler, and of course I'm going to set the order as well, so 10 or whatever, something. And there's that, and then the other thing I need to create is a WebSocket handler adapter, okay? Like this. Good. And then the next thing I need is a WebSocket handler, and this is actually our business logic. So think about what I'm going to do here. I'm going to create a thing that is asynchronous. It doesn't just return the reservation data, it's going to return a stream of values that will never stop. And so here I'm going to create a simple bean that just produces new data all the time, okay? Flux greetings response, okay, like so, greet, and I'm going to create a greetings request, okay? And I haven't defined these types, so let's do that right now. All right, class greeting response and class greeting request. Good stuff. So I'm just defining 2 types, and the response has a greeting in it. So private string message, and the request has the name of the person to be greeted. All right, so at data, at all_args_constructor, at no_args_constructor. That's beautiful. Okay, and I'm going to take that and paste. Good stuff. So now, I've got this simple service. It's a simple thing that will produce data for me. It's a never-ending stream. In order to do that, I'm going to use a publisher. Okay, so I'm going to say stream.generate a new stream from a new supplier, and I'm going to create a new greetings response using the request.name. So what is it, bom dia, like this? No? Yes, okay. Request.getName at instant.now, okay? Good, so there's my greeting. Now the thing is, this is going to create a never-ending stream. It's a stream that will go forever. So what I want to do is I want to delay it. I want to stagger the results. So what I will do is I will introduce some time. See? I can delay it by 1 second there. And the reason I want to do this the reason I can do this is because there is a scheduler behind the scenes that controls threads. So down here, when I wanted to write data to the database, remember, each line is on a different thread. It could be. It doesn't have to be, but it could be. And that is controlled by the scheduler. By default, you have one thread per core, right? And you can control that if you want. You can override it by using a custom thread pool backed scheduler like this, right? I don't need to. You shouldn't need to. It's considered like a code smell if you do that. But if you need to, it's there, okay? So now I've got my greetings producer. Let's actually produce a response here. So producer. And what I'm going to do is I'm going to say, okay, when the session comes in, when I am connected to the client, or when the client connects to my service, I will be given a brand new WebSocket session. And I'm going to receive WebSocket messages. And I'm going to map each WebSocket message into some text. And I'm going to map each one of those into a greetings request, aren't I? So new greetings request, passing in the text. That's the name. And now what I want to do is I want to take each greetings request and call producer.greet like that, okay? And that's going to give me a stream of greetings responses that I want to turn into text and then send back into the WebSocket as a text message. So session.textMessage. Okay? So I'm creating a reactive stream. I'm responding to requests that come in, and I'm turning them into strings that get sent back out like that. And it's all very, functional and lambda-e and all that stuff. Okay? Now, the result of this all is a stream of WebSocket message, is a publisher of WebSocket message. I'm just going to send that session.send like so. Okay? There we go. Send. Good. So there's my WebSocket handler. Now, of course, this could be a lambda. There we go. Restart. Now, in order to demonstrate this, I need to have something to use it, a client, right? And so I need to do something now that I'm not proud of, something that I only do because I think we're friends. Okay? What I'm going to do is some JavaScript. File, WSHTML, body, HTML, script. And I'm going to say window.add event listener, load, function, e. And then I'm going to create a WebSocket event, a WebSocket client, WS, localhost. And what did I call it? I called it WS greetings. Okay? So 8080 greetings. And I'm going to say add event listener, open. And when the WebSocket client is opened, I'm going to initiate a request. I'll say ws.send a name, and I'll say what name, var name to greet will be window.prompt. Who should we greet? Okay? I'll say name to greet. Good. Now, in order to get the data that returns, I'll say on message. Let's listen for the message, and log it out on the console. New greeting. Message.data. Okay? Good stuff. So, what do we say? Localhost, ws.html, 404, localhost 8080. Did I not do that correctly? WS. Unexpected, okay. Oh, friends. Obviously, you need to tell Spring about your configuration, otherwise it won't care. So that endpoint wasn't registered because it didn't know to look for the beans there. So now, who should we greet? Bob. All right? There you go. Every second, forever. Now, the point of that is that we're not actually blocking the thread on the server side. Right? It's each time it's going to publish an event, and then the thread is reused by something else. So you understand now that you can use publishers to create very simple stuff, and it's easy to do what we can already do. The real possibility comes when we take reactive programming and go further. So far, we have done reactive MongoDB. We're not blocking anywhere in MongoDB. MongoDB is a good example of a database that works naturally, very nicely, with reactive APIs. The driver is natively reactive. It's asynchronous I/O from the bottom up. It's not just a reactive facade on top of something that is blocking. And there's some nice things there. You can do transactions, you can do tailable queries. I like MongoDB, but my question is, how many of you are using MongoDB? Okay, good. How many of you are using a SQL database? Okay, the large majority. So let's say that I want to go back and change my data layer. Well, a question people ask is, can I use Reactive Sequel? And we don't, there's not been there's not been a great option here for a long time, right? There's github.com, R2DBC from Pivotal, and this is, I think, a good choice. But keep in mind, this is not yet GA. It's a simple SPI that supports natively reactive SQL data store integrations for PostgreSQL, Microsoft SQL Server, and H2, and there's even a third-party one supporting MySQL. We can use this in our code, but there is no, right now, for the moment, there is no auto configuration out of the box in Spring Boot. So we have to add it ourselves. So what I'm going to do is I'm going to go to my build and add these dependencies, right? These dependencies here, supporting MongoDB, supporting Postgres, and Spring Data R2DBC and PostgreSQL. I'm going to comment out MongoDB. I don't want MongoDB in this example for the moment. And because of that, I will have to change some things. First of all, that goes away. And second of all, I no longer have a primary key of a string. Instead, I have a monotonically incrementing ID, right, like this. In order for this to work, I also need to connect my application to the database. Okay, so extends abstract R2DBC configuration. And I'm going to override a connection factory. So I'm doing a little bit of the work that you would normally not need to do in the future, right? In the future, this would be done for you automatically by Spring Boot. Now, this is a configuration class, and it's going to have R2DBC repository support. In order for me to connect to my database, I need to tell it where to go. So I'm going to do something terrible. I'm just going to write the information here on the stage. Don't tell anybody, okay? It's just a secret between us, just us friends, okay? So localhost and go. So now the application, pSQL, orders, select all from reservation. There we are. There's our names, okay? And we had it in MongoDB as well. So we can see now the IDs are primary keys, right? We're using primary keys to do Reactive Sequel. I like this. I like R2DBC. It gives us a path forward for the existing applications using SQL data stores. Not all databases are supported, but more are coming all the time. So if you have one of those 4 databases, we'd love to see you try it and let us know what we can do to make it better. Now, I'm going to say something pretty controversial here. This is kind of scandalous, okay? I think that HTTP is going to be big. I think people are going to use it. They're going to like it. Right? HTTP has a future. I think it's a great document retrieval protocol. But there is a discussion to be made that it's not a great application protocol. Is that okay? Is that fair? And what I mean by that is that there are certain kinds of message exchange patterns that aren't well supported by HTTP. Right? So for example, HTTP does request response. I make a request, I get a response. That's very simple. But what about server-side push? How do I push the data down? Well, I could do server-side events. I could do WebSockets, right? But in server-side events, it's all text. How do I encode data that's binary using server-side events? I have to base64 encode it and then unencode it on the client. What about security for both WebSockets and server-side events? There's no headers, right? There's no message frame in those messages for headers. How do I propagate a security token for these kinds of things? These are basic things that all applications need and yet aren't addressed by these basic protocols. And so a lot of high-scale organizations that want to do a better job, that cannot afford to lose so much bandwidth and so much inefficiency on HTTP, have used RPC, or some sort of binary message encoding. So Google, very famously, they created gRPC. Anybody here using gRPC? gRPC? Okay, some people are using it, right? It makes sense for certain use cases. It uses and requires Google protocol buffs, so that's okay. Salesforce, do you have Salesforce? Salesforce, is that a thing down here? Salesforce is a company that is in the Bay Area where I live, and they have a terrible, ugly-looking tower in the middle of the city. And they created a Protalk gRPC compiler that uses Reactor, our project Reactor. That's okay. There's another small website where I come from in San Francisco in the Bay Area called Facebook. You have Facebook? Anybody using Facebook? I don't use it. Okay, as far as I understand, it's to spam your friends and your family. Right? You just put messages on there and it bothers everybody in your family. I don't know what it does. I'm sure it's popular. Anyway, the point is they are apparently a very big website now, and they need to scale. So they created a binary protocol called OurSocket. And OurSocket is supported in Spring Framework 5.2. So what I'm going to do is I'm going to create a OurSocket controller here. Okay? Now OurSocket supports it's binary data by default. You can use whatever message encoding you want. It supports 4 different message exchange patterns. So request response, single value in, single value out, single value in, stream out, stream in and stream out, and stream or single value in and no response, like fire and forget, okay? So you can create OurSocket services, and they also have an interesting extra thing. It's built by the team that came from Netflix that built RxJava. It's natively reactive. The protocol is built to support reactive streams of data, okay? It's not just like RPC. It's actually asynchronous reactive RPC on the network protocol. There are C++ bindings, JavaScript bindings, and Java bindings. The Java binding from Facebook uses Reactor. And you can imagine what kind of scale that gets used at, right? So we're going to use OurSocket here. It's a service that we're going to use. Okay, so I'm going to create a greetings OurSocket controller, okay? And I'm going to create a publisher of greetings response, greet, given a greetings request. Does this look familiar? In order to do that, I'm going to inject my greetings producer. And we'll say at required args. And I'm going to say message mapping. Greetings. So this is the mapping. How does the client find this endpoint in the service? Normally, if you use OurSocket directly, you end up creating this switch statement, basically. But I'm just going to use OurSocket like that. That's my service. In order for me to start it up on the server, I need to specify which server I want to run on. So I'm going to say port 8000, right? There we go. Now, on the client, I want to create a client to talk to this. So I'm going to go back here, and I'll just create a client, okay? Reservation client. And I'm going to bring in OurSocket itself, and I'll bring in the Reactive Web and Lombok, and there we go, okay? So I'm just going to bring in the basics here. And my Reactive my Reactive OurSocket service, I'll open up the client here in my IDE. Now keep in mind, OurSocket also has an extra thing that's very nice. It has the ability to tell you its uptime. In the protocol itself, there is information about the service's health. And you can change what shows up there, but it's a good way for clients to do very smart load balancing. Imagine you connect to the service, and the service says, hey, I'm too overwhelmed. I have too many users. You go to somebody else, please, right? You don't have, this is what Actuator does. If you're using Spring Boot, you have the Actuator. This does that for you now. It's in the wire protocol itself. So let's see, where's my client here? And in the client, we're going to, I'm going to create a OurSocket client. So OurSocket client. And in order to do this, I'm going to do something terrible, something that you should never, ever do at home, ever. Not even when nobody is looking and you're all by yourself. I'm going to copy and paste some code. Okay? So here's my client types, and I'm going to run this application on port, let's say 9090, and I'm going to create a simple API adapter, not a gateway. And for more on gateways, you should see 5 more minutes. Okay, you should see Spencer Gibbs' talk on gateways, API gateways later today. That's going to be good. I won't focus on gateways. We're going to create a simple API adapter, and that API adapter is going to be an HTTP endpoint that just streams the data across the wire using OurSocket. So I'm going to create another functional reactive endpoint like this, .route, and I'm going to route, come on, wrong one. Where'd it go? Good. Okay, this one, that one, this one. Did I choose the wrong Spring Boot? No, I did. Whatever. And route. Get. Okay. And it's going to be greetings. I'm going to stream the greetings here. New handler function. Actually, better yet, let's just do a Spring MVC style controller. Class greetings HTTP controller. Get mapping greetings name flux of greetings response. Greet path variable string name. And in order to make this network call, in order to make that call, I'm going to use a OurSocket client in order to get the data. So I need to create an OurSocket instance, first of all, like this. Okay. Return OurSocket dot factory dot connect dot transport TCP client transport on port 7000. Is that what I said? What was the port over here? Application 8000. So it'll be 8000. Start block. Okay, and before I connect, I need to connect with the MIME type. Right, I'm going to use a MIME type utils application JSON UTF-8 value, and frame decoder will be this one. Okay, so there's my basic OurSocket reference, and I can use that to create an OurSocket requester. Whoops, OurSocket requester. So I'll say return OurSocket requester dot create, passing in the OurSocket reference. I'm going to change the MIME type, this one. I'm going to use a OurSocket strategy that I'm going to inject OurSocket strategy. Okay. There's my client, and in order for this to work, I'm going to make this a endpoint that serves server-sent events. Okay. So produces media type dot text event stream, value is that, and in order to use this, I'll use private final OurSocket requester. Okay, required args constructor, return this dot requester dot route greetings dot data new greetings request, passing in the name, retrieve a publisher of greetings response dot class. Okay, so I'm creating a server send event endpoint on a different port. What's my oh. So this is my client running a port 9090. And we know that if we go to 9090 / greetings / name, it's going to call my service, my OurSocket service, on port 8000. 9090 greetings Sao Paulo. All right. Obrigado, my friends. Thank you so much. I hope you got something out of it. It's been a lot of fun. I appreciate it. I hope you see the possibilities here. Did you learn something? Did you learn something new? Anybody? Okay, good. I appreciate it. Obviously, I like this stuff. I'm wearing the Spring t-shirt and the Spring underwear. Of course, I'm a big fan, obviously. But you don't have to take my word for it. Like I say, Netflix, Facebook, Alibaba, eBay, lots of other companies are building on Spring Boot and Spring Cloud and Reactive to build better software faster, to get to production faster. And that, at the end of the day, is all that really matters. Obrigado. Thank you so much.